Alrighty, so let's have a look at question 6 from last year's Specialist Mathematics exam. So to begin with, we've got a polynomial here. The first question asks us to state for which values, what values of n can take. So here, to ensure this is a polynomial, n, select that one, n has to be greater than or equal to 0. Fairly straightforward, that one. Okay, moving on to the next one. So we've got polynomial, and we want to show if x minus 1 is a factor, what values, or state the two values that a can take. So if x minus 1 is a factor, then from that we can deduce that p of 1 equals 0. Therefore, putting that back into our polynomial, we've got a squared plus 1, replacing the x by 1, and 1 minus 2 to the power of n plus 2a equals 0. Therefore, a squared plus 1 minus 1 to the power of n plus 2a equals 0. We want to look at two different cases if n is odd to begin with. If n is odd, then minus 1 to the power of n will end up being a negative, or minus 1. So we get a squared plus 1 times minus 1 plus 2a equals 0. Therefore, a squared minus a squared take 1 plus 2a equals 0. A squared take 2a plus 1 equals 0. Just rearranging the previous line. Factorising that, a minus 1 squared is equal to 1. Is equal to 0, I should say. Cross that out. And then finally, a must equal, let's just clean that up, a must equal 1. So the second case, if n is even, minus 1 to the power of n is then going to equal just 1. A squared plus 1, 2a equals 0. Therefore, a squared plus 2a plus 1 is equal to 0. Factorising that, a plus 1 squared is equal to 0. Therefore, a is equal to minus 1. Okay, so we've got two cases, when n is odd and when n is even. So, moving on to question C. So, the first part relates to the previous question. The second part, we're told when we have a remainder of, we get a remainder of minus 164 when we divide by x plus 1. So that's the same as saying p of minus 1 equals minus 164. Again, we're going to use information from the previous section, so we're going to break it up into two parts. So firstly, if n is odd, then we know that a is equal to 1. Therefore, minus 164, substituting back into this original polynomial up here. So we've got 1 squared plus 1 times minus 1, and then minus 1 take 2 to the power of n plus 2. Oops. So that's just taking that 2 over to the other side. Therefore, minus 83 is equal to minus 3 to the n. Sorry, that should be a plus 83. In this case, n is odd, so we end up with 83 positive number is equal to minus 3 to an odd power, which is not possible, so we'll write down no solution in that case. So looking at the other case, when n is even, we've got a is equal to minus 1, so therefore we've got minus 164 is equal to minus 1 squared plus 1 plus 2 times minus 1. Taking that over to the other side, that becomes minus 162 is equal to minus 2 times minus 3 to the power of n. Dividing through by the minus 2, we get 81 is equal to minus 3 to the power of n, and therefore n must equal 4, which is consistent with the fact that n is even. So the only solution is n equals 4, a equals minus 1.